Hello all, welcome back to the channel. This is the part two of the video that we are doing on Databricks' platform basics. In our last video, we had discussed this Databricks' overview, architecture, cluster types, cluster pool, configuration, and runtime. So let's continue that, and we will be seeing the other things which are left in the component section. So let's get started there. So yeah, we had gone through till this like cluster pool. So we will be going through the other things like just a recap of the cluster pool. For example, if we have automated jobs that we are scheduling, so it will just ask the cloud provider to provision those nodes for the cluster, and it will be slow. We will have to wait for the cloud provider to run. So when what we can do is we can attach a pool of VMs which will be kept on running and it will be warm. So if there are enough idle instances in the pool, the cluster acquires them and starts and scales very quickly. If there are not enough idle instances, the pool expands by allocating new instances from the cloud provider to satisfy the cluster request. So this way the cluster pooling works. And when we set up pools in Databricks, we can define the uptime and shutdown period like minimum idle instances, idle instance, auto termination. So these will help in saving costs. Let's say the next component that we will have is Databricks Notebook. So the most of the work that is done in the workspace is on via notebooks. So notebook is a web-based interface which is composed of group of cells that allow us to execute commands. So this command that we are looking at is it can be Python, Scala, Java, or SQL. So those not Java, Scala, Python, and SQLs are there. It also supports Markdown. We can have widgets and everything. So this is this also helps us in parameterizing the notebook. Let's say if we want to run that notebook in future, then we can use this parameterization and widgets to make it run or may make it more configurable. This runs the cell in a notebook is works on REPL site. So uh, it will we will type the command, it gets dispatched to the backend, and then the output is returned back to the cell itself. So when a notebook is detached from a cluster, the execution context is removed and all the computed variables are cleared from the notebook. That is something we have to note. So because that all the memory or all the context of that notebook remains with the cluster. We can share notebooks and can be imported as well. So this is good thing. That, like, for example, you can like you can work collaborative with, let's say, two folks working on the same team. They can share the notebook and do the work in more faster way. Utilities. So Databricks has a lot of utilities that we can use to perform various tasks. For example, utilities are linked to credentials, data. So credentials is a utility which allows us to get credentials within the notebooks. Our data, which is a utility for understanding and interacting with data sets. Then we have FS, which is a utility for interacting with the Databricks file system. Then we have utilities for jobs, which allows us to leverage job features. We have a utility for meta, which is for hook into the compiler. Then we have utilities for notebook, which allows us to manage the control flow of notebooks, like for example, dependency management or order in which the different notebooks can be executed. Then we have utilities for secrets, widgets, APIs, and everything. So yeah, there are different utilities which are available that we can leverage to get our things done in Databricks environment, or we can create complex workflows as well. Then we have Databricks job. So job is a set of predefined tasks that we want to execute uh, on an environment, and the task includes, it can be a notebook job, it can be a Spark Submit job, it can be a Spark SQL job, and so on. So what we do is we define the compute resources for each task and then multiple tasks defined for the same job and can use the same compute resource. So this will be happening like we can have a job configuration which says that task 1, 2, 3, or let's say we are doing an ML work. So we will say all the compute intensive workload will tasks will be running on, let's say those are task 1, 2, 3. They will be running on compute optimized cluster. And then we can say other tasks which are, let's say, memory emphasized and memory intensive can run on a different compute pool. And that's how we will be getting best of everything. And then we can orchestrate using the job configuration. So this is how job allows us to help. And we can also create tasks. Like for example, if we have a pipeline, so moving from data from bronze layer to silver layer to gold layer, doing some transformation in the silver layer. So those kind all those things can be orchestrated using the job. Now we also have Databricks CLI. So this CLI allows us to interact with Databricks environment. So for example, let's say if we are working with VS Code or somewhere else, so we can't always go back to the UI and do something and then come back. So this CLI helps us in automating few of the stuff. For example, notebook creation, cluster creation, job configuration, everything can be done using the CLI itself. Database file system. So this is a distributed file system that provides a layer of abstraction over the object storage. So for example, as I mentioned, when we create a Databricks account, we create a workspace, we attach a workspace to a, storage layer, which is nothing but an uh, S3 or can be GCS or Azure Blob Storage as well. So this DBFS provides an abstraction on top of it, so that we don't have to know the internal workings of that particular object storage system. We can treat this as an unified way of running commands or running operations on those objects. So that's what DBFS does. So DBFS provides us a convenience by mapping cloud object storage URIs to relative paths. So we when we are running things in our cluster, it will behave as if that those things are relative to that cluster rather than being in object storage. And it has several default directories that is available on the workspace, like file store, Databricks datasets, Databricks results, user high warehouse, and everything. So those are there. And then we have a new concept called volumes in Databricks SQL. So volumes are Unity catalog objects representing a logical volume stores in the cloud storage location, and they provide capability for accessing, storing, governing, and organizing files. A volume can be either managed or external, and the path to access the files in the volume is like, for example, we'll have to say volume, then catalog identifier, then schema identifier, then volume identifier, and then path to the file name. So if you see, this is how we create a volume, create external volume, and then we read it from volumes location. So this is another way of accessing data from S3 in the workspaces. Uh, then we have a concept of Delta Lake. So Delta Lake is an open source storage layer, which was actually built by Databricks team, but later on made available for everyone else because it was open source. And Delta Lake it allows us, I mean, it basically creates a layer on top of the files that we have. For example, in this case, everything is in Parquet format. So it will create an abstraction on top of it. So the files in object storage will behave like as they are tables. And that's what this Delta Lake does. And it has certain features, like it offers ACID transaction, it has scalable metadata, it allows us to time travel, it has a schema evolution, it can do uh, audit history as well. So these are some of the features of Delta Lake. Then we have Unity Catalog. So Unity Catalog is nothing but a management layer in Databricks. It allows us to govern or manage or have a registry of the things that are or the objects that are present in the environment. So it can map to objects like data, ML models, analytics artifacts, storage. So it has metadata of everything, and we can govern based on certain attributes that who will have access to what. So this is what Unity Catalog will do. And it is also possible for us to visualize the data lineage using the Unity catalog, because there are some features in the Delta which allows us to do a row level lineage that is also visible in the Unity catalog. So the structure wise, Unity catalog has some things. For example, it has a meta store which has storage credential, external locations, catalog. So in catalog we have schema. Then in schema we can have manage table, external table, view, model, and function. Then we have share, recipients, and provider options as well. So share is if we want to share some data, a recipient is who will receive, and provider is who is providing that particular resource. So these are some of the concepts in Unity catalog. Then we have Databricks workflows. I had discussed the Databricks jobs, right? That has now been made a full-fledged itself project, which is Databricks Workflows. It's a newer offering. So earlier it was jobs, now it has been renamed to Workflows. Workflow is something which allows us to uh, do the same stuff that we were doing with single job, but now it allows us to work with multiple jobs. So we can create variety of tasks like notebooks, SQL scripts, Python code, Delta live tables, or even jar files. We can run those, and this workflows offers a GUI as well for task management. We can have dependencies between the task. We can have trigger also, like we can trigger what means is when it will run. It can be batch scheduled execution, or it can be a trigger based on some other system. And then it can be continuous execution as well, that we want to run it all the time, like, or maybe we want to run it every 5 minutes. That also is possible in this. So this was I will say these are the basic concept that we must know before we start working with Databricks. Uh, we in next set of two videos that I will create, I will discuss more about some of the advanced concepts which are in Databricks. So till then, have a nice time, and if you like these videos, do support the channel. Thanks.